have used Linux before? I'm just curious. All right, that is a lot of you, a large percentage. So we're going to start with what an operating system is. So there's different types of operating systems for different devices. You think of your phone, that's going to be Android or iOS, depending on what kind of phone you have. You can think of computers, you could have Mac OS, you could have Windows, you could have Temple OS. There's lots of different types of operating systems. What they do is they're the interface between the hardware and the software on your computer. So between the user and the actual computation going on, making everything work for you, that's your operating system. And yeah, so where is Linux used? That's a common question because you probably don't see a lot of Linux everywhere, but every single computer needs an operating system, which is going to include smart devices such as toasters, fridges, or smart fridges, not every fridge, and even cars have operating systems. So many modern cars are coming with operating systems on their computer. So your car probably runs Linux. Every server, every website you go to is running an operating system, and for a majority of those, they're going through AWS or something like that, and on the back end, it's Linux. So Linux is used in a lot of places. Also kind of interesting, the International Space Station runs Debian Linux. So there's lots of different distributions of Linux, like different versions you can think of it as. The International Space Station is running one of those right now. Debian is one of the most stable versions of Linux, so that's why they use it. So why should someone use Linux? That's like the main question you hear. Why should someone actually care? Well, you don't have to. It's fine to keep using Mac. It's fine to use Windows. But there's lots of good reasons to use it. So for me, I started because of ethics, actually. So they've got free licenses, free open source software. It's like the foundations of everything that's built. So I just thought that was cool to use something from the base and not like some top level software. It is very fast. Right, yeah, so the smallest Linux distribution I can find is 17 megabytes, which is kind of impressive because that's an entire operating system fitting within like the size of an image. Whereas like, I don't know the exact numbers, but many of them are measured in gigabytes, like 5 or 6 gigabytes for lots of distributions. And I think Windows was about that. So one of the benefits of using Linux is that it's designed for servers. It's designed for high uptimes. It's designed to keep on running for a very long time. You can think of Windows, like Windows, Mac, they're both very stable, but Linux is especially developed for servers, which need that high level of reliability, consistency, and can keep running. They can like take, for example, entire operating system upgrades, live kernel patches without rebooting, which is very important in lots of industries because you can't have your server go down every time your computer needs an update. So, yeah, that's a good reason to use it. For other people, it's just because it's extremely configurable. So Linux being open source in nature, everything is modifiable. So if you get like excited about like you can make your computer run however you want it to, then it's probably for you. You can change all the settings, you can change settings you're not supposed to, and it will let you delete your, like on Windows, like if you have it, you can try right now, it won't let you delete system32. But on Linux, if you wanted to, it's your computer. You can delete your boot file, you can delete your boot drive. You can do whatever you want, like it's your computer. So
are you sure that's supposed to be a plus point?
Yeah, it's technically a plus because it's your computer. So you're free to do whatever you want, which is a big part of it. Yeah.
Can we have a live demo?
Okay. would destroy your computer. Don't run this. Yeah, you can do to your virtual machine when you're done if you want to. You won't be able to use it after. You could. I don't have time to do that, but if you want to run it right now and use someone else's, go ahead.
If you don't like it and wanna get rid of it.
Yeah,
The way to
exactly.
the back.
That's the best way to delete it. So,
Wait, but how do you get into this console?
this console, right, so you can press Control-Alt-T, and that, I don't know why. Yeah, and you should, it's also on the left side of the dock, you can click on this terminal. A lot of stuff you'll find in Linux, they like to make it keyboard-based, because it's a bunch of like nerds that are really fast and into computers, and they're like using their keyboards, but you can use your mouse too. So, yeah, it's free as in freedom. You can delete the operating system if you want. It's not going to stop you. I can't get my mouse back. That's weird. There we go. And also, if you're into cybersecurity or if you're in computer science, you don't have to use Linux. Like, no one's gonna force you to. A lot of people won't force you to use Linux in computer science and in cybersecurity, but a lot of people will judge you if you don't. So if you want to avoid that, it's beneficial. Yeah.
Another question. So a lot of jobs on the job board related to software engineering require Linux. So what exactly are we using Linux for? Software engineering.
Mainly servers. Probably if you're working on server-side code, they're going to be running Linux, but it's also just familiarity with the system, because it's like another skill, another tool in your tool belt is being able to use Linux. You don't want to walk into your job not knowing how to use a computer for a computer-oriented job.
Right.
For requiring Linux, yeah, the best thing I can think of is the servers.
So they just want you to have it.
Yeah. Also, if they have like a system set up for their DevOps or whatever, you're going to be working nicely with them. Yeah. Okay, so you guys have already done this part, but I'm still going to go over ways to install Linux. As you mentioned, you can dual boot, which is installing Windows and Linux both onto the same computer. Different than what we're doing. Virtual machines are different. I'll get to those. Let's go over direct booting or single booting first. So the same way you have just Windows on your computer probably, or just Mac, you would install Linux and replace Windows. Delete it, so you're just running the computer with Linux. That's like the way I use it. I think Sandra, you also use that. Like eventually you might start doing that. Yeah.
Did you just say Windows doesn't let you delete certain files? So if we download Linux, how will that delete Windows?
Sorry?
Yeah, you just said that Windows doesn't let you delete certain files like system.
Right. So you actually go beneath Windows and install the operating system there. So when you power up the computer, usually you press F2 or F12 to get to the BIOS. That's a basic input-output screen.
Yeah.
And from there, Windows hasn't even loaded yet. You would put Linux in at that time. You boot the Linux drive. Windows never starts. And then you boot the drive for Linux, install Linux, it deletes the Windows. So Windows can't delete Windows, but Linux can delete Windows. Yeah.
Get him in the sleeve.
Yeah, exactly. Right, so that's about the process you would use to install Linux directly, and it's a similar process for dual booting, but you've got to be careful not to kill Windows at that point. So that's how you can have multiple operating systems on the same computer that do not rely on each other. What we're doing right now is called using a virtual machine. So your host OS is probably Windows or Mac, and the virtual machine, you can think of it as a guest operating system, and it's running on top of your host. So you still have your entire host loaded, Windows loaded, and then you load Linux on top of that. And that uses more resources. It's maybe not as efficient, but it can be more practical if you use Linux like on the off chance, or you don't want to get rid of your old computer.
And it's useful to test for viruses.
Yeah, that too. There's one specifically for that too, like QTOS. Yeah. The other option, I'm not really into this, but the guy that does it normally is not here. It's called called Windows Subsystem for Linux. So it's kind of like a virtual machine, except you just have the command line and restricted access. So you're kind of running Linux as an application for Windows instead of a guest on top of Windows. Does that make sense?
How do you use an OS to run another OS?
So it wouldn't be like running the operating so much as looks a little under the average. You guys all look like you know what you're doing already, but we're still going to go right from the beginning. So there should be nothing you need to know other than have a computer and have the VirtualBox image already set up, which you should already have done. Okay?
Before you came here.
Yeah. Some of us not yet. So you do not need to know any Linux beforehand. We're going to go straight from the beginning, and like the target audience first year CMS students, but anyone is welcome. Yeah, let's go. Okay, so how many of you have used Linux before? I'm just curious. All right, that is a lot of you, a large percentage. So we're going to start with what an operating system is. So there's different types of operating systems for different devices. You think of your phone, that's going to be Android or iOS, depending on what kind of phone you have. You can think of computers, you could have Mac OS, you could have Windows, you could have Temple OS. There's lots of different types of operating systems. What they do is they're the interface between the hardware and the software on your computer. So between the user and the actual computation going on, making everything work for you, that's your operating system. And yeah, so where is Linux used? That's a common question because you probably don't see a lot of Linux everywhere, but every single computer needs an operating system, which is going to include smart devices such as toasters, fridges, or smart fridges, not every fridge, and even cars have operating systems. So many modern cars are coming with operating systems on their computer. So your car probably runs Linux. Every server, every website you go to is running an operating system, and for a majority of those, they're going through AWS or something like that, and on the back end, it's Linux. So Linux is used in a lot of places. Also kind of interesting, the International Space Station runs Debian Linux. So there's lots of different distributions of Linux, like different versions you can think of it as. The International Space Station is running one of those right now. Debian is one of the most stable versions of Linux, so that's why they use it. So why should someone use Linux? That's like the main question here. Why should someone actually care? Well, you don't have to. It's fine to keep using Mac. It's fine to use Windows. But there's lots of good reasons to use it. So for me, I started because of ethics, actually. So they've got free licenses, free open source software. It's like the foundations of everything that's built. So I just thought that was cool to use something from the base and not like some top level software. It is very fast. Right, yeah, so the smallest Linux distribution I can find is 17 megabytes, which is kind of impressive because that's an entire operating system fitting within like the size of an image. Whereas like, I don't know the exact numbers, but many of them are measured in gigabytes, like 5 or 6 gigabytes for lots of distributions, and I think Windows was above that. So one of the benefits of using Linux is that it's designed for servers. It's designed for high uptimes. It's designed to keep on running for a very long time. You can think of Windows, like Windows, Mac, they're both very stable, but Linux is especially developed for servers which need that high level of reliability, consistency, and can keep running. They can like take, for example, entire operating system upgrades, live kernel patches without rebooting, which is very important in lots of industries because you can't have your server go down every time your computer needs an update. So yeah, that's a good reason to use it. For other people, it's just because it's extremely configurable. So Linux being open source in nature, everything is modifiable. So if you get like excited about like you can make your computer run however you want it to, then it's probably for you. You can change all the settings, you can change settings you're not supposed to, and it will let you delete your, like on Windows, like if you have it, you can try right now, it won't let you delete System32. But on Linux, if you wanted to, it's your computer. You can delete your boot file, you can delete your boot drive. You can do whatever you want, like it's your computer. So,
Are you sure that's supposed to be a plus point?
yeah, it's technically a plus, because it's your computer. So you're free to do whatever you want, which is a big part of it. Yeah.
Can we have a live demo of
Okay. So, yeah, this would destroy your computer. Don't run this. Yeah, you can go to your virtual machine when you're done if you want to. You won't be able to use it after.
Wait, maybe I'll just all get it, no virtual machine.
You could. I don't have time to do that, but if you want to run it right now and use someone else's, go ahead.
If we don't like it and wanna get rid of it, this is
Yeah,
the way to
exactly.
handle the time.
That's the best way to delete it. So,
Wait, but how do you get this console?
this console, right, so you can press Control-Alt-T, and that, I don't know why.
Okay, but
Yeah, and you should, it's also on the left side of the dock, you can click on this terminal. A lot of stuff you'll find in Linux, they like to make it keyboard-based because it's a bunch of like nerds that are really fast and into computers and they're like using their keyboards. But you can use your mouse too. So, yeah, it's free as in freedom. You can delete the operating system if you want, it's not going to stop you. I can't get my mouse back. That's weird. There we go. And also, if you're into cybersecurity or if you're in computer science, you don't have to use Linux. Like, no one's going to force you. A lot of people won't force you to use Linux in computer science and in cybersecurity, but a lot of people will judge you if you don't. So if you want to avoid that, it's beneficial. Yeah.
I got a question. So, a lot of jobs on the job board related to software engineering requires Linux. So, what exactly are we using Linux for? Software engineering?
Mainly servers. Probably if you're working on server-side code, they're going to be running Linux. But it's also just familiarity with the system because it's like another skill. Another tool in your tool belt is being able to use Linux. You don't want to walk into your job not knowing how to use a computer or a computer-oriented job.
Right.
For requiring Linux, yeah, the best thing I can think of is the servers.
So they just want you to have it.
Yeah. Also, if they have like a system set up for their DevOps or whatever, you're going to be working nicely with them. Yeah. Okay, so you guys have already done this part, but I'm still going to go over ways to install Linux. As you mentioned, you can dual boot, which is installing Windows and Linux both onto the same computer. Different than what we're doing. Virtual machines are different. I'll get to those. Let's go over direct booting or single booting first. So the same way you have just Windows on your computer probably, or just Mac, you would install Linux and replace Windows. Delete it. So you're just running a computer with Linux. That's like the way I use it. I think Sadra, you also use that. Like eventually you might start doing that. Yeah.
didn't you just say Windows doesn't let you delete certain files? So if we download Linux, how will that delete Windows?
Sorry.
Yeah, you just said that Windows doesn't let you delete certain files like system.
Right. So you actually go beneath Windows and install the operating system there. So when you power up the computer, usually you press F2 or F12 to get to the BIOS. That's a basic input-output screen.
Yeah.
And from there, Windows hasn't even loaded yet. You would put Linux in at that time. You boot the Linux drive. Windows never starts. And then you boot the drive for Linux, install Linux, it deletes the Windows. So Windows can't delete Windows, but Linux can delete Windows.
So
Yeah.
just get him in the sleep.
Yeah, exactly. Right, so that's about the process you would use to install Linux directly, and it's a similar process for dual booting, but you've got to be careful not to kill Windows at that point. So that's how you can have multiple operating systems on the same computer that do not rely on each other. What we're doing right now is called using a virtual machine. So your host OS is probably Windows or Mac, and a virtual machine, you can think of it as a guest operating system, and it's running on top of your host. So you still have your entire host loaded, Windows loaded, and then you load Linux on top of that. And that uses more resources. It's maybe not as efficient, but it can be more practical if you use Linux like on the off chance, or you don't want to get rid of your old computer.
And it's useful to test for viruses.
Yeah, that too. There's one specifically for that too, like QZOS. Yeah. The other option, I'm not really into this, but the guy that does it normally is not here. It's called Windows Subsystem for Linux. So it's kind of like a virtual machine, except you just have the command line and restricted access. So you're kind of running Linux as an application for Windows instead of a guest on top of Windows. Does that make sense?
How do you use an OS to run another OS?
So it wouldn't be like running the operating so much as emulating it. Like you can open PowerShell in Windows and then switch to a Linux command line. It's going to be something like that. And it's just a whole bunch of like configuration and stuff like that.
I'm gonna pretend that didn't just go over my head.
Okay. It's not too, like a virtual machine's better and easier, so I'd say just use a virtual machine, but there's some people that would disagree with me. He's not here right now though. So let's go over actually Linux now, because all that was like a lot of dry, boring stuff, but not that Linux isn't always, but what you have are, when you're building your Linux installation, you usually start by choosing a distribution. So I was talking about this a little bit earlier. Distributions are all the different versions of Linux. Each of them has like their own niche and setting. And this is where it's kind of interesting because you can choose how your computer is going to run. So does anyone know any distributions or want to talk about any? Yeah. Arch, of course. Okay, so what we're running right now is called Ubuntu, and it is based off of Debian. Debian is that super stable one I was talking about earlier on the International Space Station. So with Debian, you're going to get slow updates, but they're going to be super stable, and that's the main use for Debian. The main reason people enjoy it is because it's stable. Ubuntu is built off of Debian, like a lot of things are built off of Debian, but Ubuntu is a little bit faster with its release cycle, and it has a nicer user interface. It feels like a more modern computer. When you use Debian, you've got a bunch of really old stuff because it's super stable, so they don't upgrade it too often. The other path, so I talked about Debian, the other path, there's a few of them, but the other main one is Arch. So Arch is called a rolling release distribution, where it is constantly updating its packages, and you're always getting the most recent bleeding edge updates and upgrades for your computer. And it's a lot less stable, however it's stable enough. Do you use Arch?
No.
No? No? Okay. It's fun. Like, it'll break on you like, twice a year. Once of them will be irrecoverable, and it's a lot of fun. But
like
yeah.
Russian roulette is fun.
Sorry?
Fun in the same way Russian roulette is fun.
Yeah, exactly. So yeah, that's Arch in a nutshell. Debian. There's also Gen 2. That's kind of more niche, but this one, instead of downloading upgrades, you're going to download the source code for all the upgrades and then compile them on your machine. It takes hundreds of hours of their time and tons of computing power, and I don't know anyone that actually does it, but it's cool that people put time into that. Any other distributions? Yeah.
Red Hat based.
Red Hat. I don't know too much about Red Hat because like they do some paid stuff. I always avoided that. But they're along the same line as Debian. I don't know. I don't think they're Debian based.
They're not.
No, but they are another option. I think the free version is called Fedora. Yeah, Fedora. Fedora is interesting. This is kind of controversial, but distribution really doesn't matter that much, even though I just talked about it a bunch. Like, if you're trying to change the look of how your Linux installation feels, you're usually going to want to go for the desktop environment. So, like, the philosophy of your system, if you want it to be super stable like a server, go for Debian. If you are okay putting a bunch of time into it, Arch, stuff like that. Like, small decisions, but how it looks, how it feels day to day, that's going to be your desktop environment. So, does anyone know any desktop environments? Yes.
Pop OS.
Pop OS, that's the one I'm using actually. That's the one, or no, this is GNOME. Pop OS is based off of GNOME. So that's going to be how your computer looks and feels. There's a few of them. There's GNOME, which you guys all have right now. If you go into your computer, it's like the desktop environment is going to be how it feels, how it looks. We can actually install different ones and completely change the computer. So I haven't tried this, but there's one called Plasma. I don't know the exact package name. Yeah. We'll look at pictures. There's going to be how the computer looks and feels. So if you prefer like a Windows-like interface, you'd want to use KDE Plasma. If you prefer Mac OS, that's kind of what GNOME is. There's also Cinnamon, which is more like Windows 7. There's also tiling window managers. So those are like for people that really like to waste their time. I did it for a year. So a tiling window manager, imagine every time you pressed a key on your keyboard, it does some completely random thing.
Yes.
Kind of. If someone else uses their computer, that's how they would describe it. So what a tiling window manager does is a lot like this, but every time you open something, it's going to, this isn't tiling, so I've got to do it manually. And it can be useful if you only use 2 or 3 windows at a time. I can't maybe do it all. It looks like this, but every time you open a new window, it just splits an existing one, places a new one. And you can go crazy configuring keybinds. Like Linux lets you configure everything that's tiling window manager is where a lot of people end up doing that. Does that kind of make sense? To someone that hasn't heard of tiling window managers before? Yeah, okay. They're not too important and you probably don't want to touch them. Okay, there was someone talking about systemd and that on the Discord server. I'm just going to go over it briefly, but it does not matter at all. There's lots of background processes running on an operating system at any given point in time, and those are called daemons. Systemd manages those. There's some operating systems that become very controversial and don't want to use systemd. And nobody should care about this because it changes nothing, but some people do. So there's sysv init, which some operating systems use instead. It doesn't really matter. Systemd is 17 megabytes, which is why it's measured in megabytes, which is why a lot of people don't like to use it, even though that's extremely small. Some say it's too big, so they use a bunch of smaller things, such as sysv init, which sounds a lot like systemd, but it's different. And another issue with systemd, people complain that it's monolithic, meaning it's one single part of the operating system. This starts to get more into software design than anything, but people don't like the structure of it. It changes absolutely nothing. When you're choosing a distribution, do not worry about like system B or sysinit or anything like that. Okay, I'm gonna stop talking about that. It's not right. Okay, so does everyone understand what a desktop environment is and what a distribution is? Okay, so part of Linux, eventually, if you're using it, you're gonna have to use the terminal. It's a big part. You can get around it just by finding apps for everything, but a lot of stuff is easier if you just use the terminal. So we're gonna run a command now. You're gonna type in echo hello world, and that's the same as print in Python. So the language we use in the terminal is called bash. The SH stands for shell. I think the BA stands for born again. I'm not sure. It's someone's name, I think. Yeah, so in the terminal we use bash. That's the language. We can also make bash scripts. We'll look into that later on. So let's go over the file structure of Linux. Right now you can press pwd. That's going to print working directory. That tells you where you are in your computer. So the same as if you open up files. Your current file path is going to be, this is your home directory. This is where you do everything on your computer. So pwd, that prints the current directory. Directory is just a fancy word for folder. To change directories, use cd. So if I wanted to change into music, I do cd music. Everything in Linux is case sensitive. So if I was in home, so if I do cd tilde, that'll be changing to home. If I did cd music, there's no such folder or directory music. To show all the directories, you can do ls, and that ls lists your current directory. To change to your parent directory, you can use cd ... means parent. And you would never really need to use this, but your current directory is dot, so if you did cd dot, that would change to where you are right now. And if you just put cd, that'll always switch to your home directory. So the importance of your home directory is, that's where all your user files are going to be. So in Linux, everything is a file, but your files are going to be in the home directory. There's a bunch of other files, so if you do cd/, this is root, and you look in root, there's going to be a lot of stuff that you do not want to touch. Remember I was saying you can delete system32, or you can delete the root folder on Linux? This is where you would do that. So it's good not to mess around in anything outside of your home directory. With that said, there are some cool folders. Yep.
What does it take screenshot?
Do you have print screen?
Oh, it's working. Okay, because I tried the Schwartz house, the window that you usually use.
Yeah.
It works.
Yeah, and you can also change keybinds if you have. Yeah. So in Linux, in your root directory, there are some interesting directories at root level. So the first one I'll go over is temp. So if you cd/temp, or if you're already in root, you can cd temp. Anything you put into this folder is deleted every time your computer reboots. So if you know a little bit about how RAM works, you can think of this as saving something onto your computer's RAM. When the computer loses power, everything in this folder gets deleted. So that can be useful if you're making scripts or you're downloading something that does not need to stay on your computer for a long time, or if you're just storing something temporarily. A lot of these are irrelevant, for most uses, but if you look inside, let's say bin, that's going to be binaries. So all the different programs your computer can run, you'll find them inside bin, or universal bin, which is a little bit different than bin. And there's a few other bins, so yeah. The other one that I was going to talk about, or the other one that's kind of interesting is UofT. I don't know if there's anything in there right now. This is where packages will install if you don't install them through apps, which I'll talk about now actually. So C.R.E.A.T.E is going to be your package manager for Linux. You might not be familiar with the idea of a package manager if you're coming from Windows, but if you think of something like iOS or Android, you've got the Play Store and you've got the App Store. Your package manager is going to be a lot like that. So it's a central repository which just stores different packages that you can install onto your computer. So we're going to update our entire computers right now. You can do that with sudo apt update. Do y'all know your root passwords? Mine started as like, I think it's changing. Yeah. I just did it so there's not much to update. What this command does is it refreshes all of the downloadable packages your computer can get. So we haven't actually updated anything yet, other than the list of things we can update. After that, we run sudo apt upgrade, and then all of those updatable things become upgraded. So what you did here is equivalent to update and reboot your Windows computer, but you don't need to reboot, which is one of the things I was talking about earlier. Your computer does not need to restart. It supports live kernel patching and updates. The other cool thing about this is in 2 commands, you updated every single app on your computer to the most recent version available. As far as I know, you can't do that on Windows, so it's cool. If you wanted to install something using apt, it's very similar. So if I did sudo apt install and then tree, and I installed it right. Then
What is C.R.E.A.T.E exactly?
I'll show you in a second. It just it displays your current file structure. So it's kind of like ls, but it looks nicer. Or if you wanted to install, I already have it, but it would be the same way to install Firefox, Steam, Vim, stuff like that. You can do it all just from this command line. And some things will be trickier because most of the stuff in repositories by nature is open source. So you might have to download something externally, and that's how it would end up in /opt. So this directory, if you download external things, that's usually where they end up instead of in binaries. Although they'll put a copy in binaries too. To uninstall, very similar process. Sudo apt, I think it's uninstall, or it might be remove. Yeah, remove. And then press yes. And that's how you can easily install, uninstall, upgrade, update software on your computer. Does that make sense for everyone? Yeah. Okay. Okay, let's install. I don't know VS Code. Okay, let's look at text editors. So, you've heard of, has anyone heard of Vim before? Vim? Okay. So, you can edit text files from your terminal with software such as Nano, Nano Vim, NeoVim. There's some more. I can't think of the names right now. Let's try Nano file.txt. I'll do that again. So Nano is the name of a text editor.
What do you mean?
didn't save it though, so I'll go over that in a second, but this is the command, just so you can see before I run it. So when you do this, you can edit text files from your computer, from your terminal, I mean. And at the bottom, it says what a lot of the commands are. I'm pretty sure Control S and Control X saves and exits. And then from there, the cat command, or what the name is for it?
How do you post it?
Control X. Yep.
After something's downloaded, where is it located after?
Right, so are you talking about downloaded through apt?
Yeah, apps.
That would be in the bin files.
Bits files?
Bin, like /bin. However, you don't want to delete it from there. What you can do instead, like the primary way you would do it is sudo apt remove and then the package name. So that would be how you would delete something that you've installed.
How do you lose the text
Wait,
file?
where's some? Where's some bits? Oh, sorry.
Oh, don't worry about bin. When you do sudo apt remove, it deletes it from bin for you.
If I just want to open it, open the thing that I downloaded. I just found that Google and
Google. You might be able just to enter Google in the command line. Or if you press Windows and type Google, it should be installed.
Windows.
Or, yeah, the Windows key.
Oh, Windows too.
Right, so when you use apt to install something,
Wait, how do you close the text file?
Control X. So, you said you installed Google.
Yeah.
So when you install Google, which one do you install? How do you install Google?
No, cool. It just said, it is a reading package, list down, building dependency tree down, reading states information down, and then there's like a right need, what's it? Okay.
Unable to look at package.
Yeah, unable to.
Yeah, okay, so it didn't install it because Google wasn't the name of the package.
Okay.
So
I'll
the
just-
error message said,
I'll
yeah.
just try it out.
Yeah, that's cool though, it's good to experiment. Definitely even experiment once this is over, get used to it if you plan on using it. It's good to get familiar with Linux. I think, is it BO9? You start using Linux the most, that's a CSC BO9. That's when you really start using it. However, also in CSC 848, it's helpful to have that experience because you're going to be working with C. Yep.
Dependency.
Dependencies.
Yeah. So how does it automatically just install that?
Right, so each package knows its dependencies, and when you install a package, it also installs its dependencies.
What is a package?
Firefox, Steam, Google.
But isn't like a package software with other stuff? Like the Debian package is different from.
So I'm using the term package kind of loosely, I guess. Are you speaking about .dev files?
Yeah.
.dev files, okay, I'm gonna get to those right away. And they are a lot like sudo apt install Google, let's say Google was there, or you could do install the google.dev file, and that would be the same as installing it through apt. And apt would actually recognize that, so you could remove it through apt after that point.
Yeah, like Node.js dependencies, when you download a package and just keep installed.
Yeah, exactly, so like npm, something like that, yeah, the package manager, I think it's, yeah. Yeah.
How long this workshop's gonna last?
7 video.
So the latest we'll get out is 7, but I don't think we're gonna go till 7. At the end, we're just gonna see if there's host. No. There's gonna be food coming though, I believe. Yeah. Okay. So you guys are using Python already for AO8, I believe, right? Yeah, okay, so you can, Linux comes pre, no,
You know, you have to add.
okay, usually when I use it first, to install Python, probably want to use Python 3.
No installation?
Yeah, okay, so this is your Python interpreter that you can use. There's other ways to use Python. Yep.
When I didn't write Python, oh wait, but understand that.
So I wrote Python 3. There's like,
Before I wrote Python 3, I wrote Python. And it said package Python has no installation candidate. What does that mean?
there is no Python package. There's a Python 3 package though.
But didn't others get a different error for that? Like the person right next to me got a different error when he tried to download something in here like this.
Really?
Like to the error. Yeah, unable to locate package.
That was, I think that was running a command. So he ran sudo apt install, or you ran just the name of the package?
I don't think I ran that.
So I'll do that again. Once you run this command,
Alright, sudo apt.
sorry.
I didn't run sudo apt.
Oh, yeah, it probably didn't work then. You need, sudo is like your administrative control over the computer. So to change the computer's files, which installing a package is doing, you need to use sudo. Has everyone run this successfully?
Okay.
I assume yes. Okay. So now, once you've done that, you should be able to run Python 3, and you guys should be familiar with scripting in Python. So you can do Python stuff in there. You can also edit Python files. So
Is there still a whole bunch of to be powered for today?
let me see.
Maybe just get started.
Yeah, we're gonna go over some commands and stuff, but
What else aside from the
importance of home directory for distro hopping. Probably, like, there's a lot of things it would take the rest of the lecture to explain all the things.
Okay, is there gonna be a similar workshop like this recently with something?
Sorry?
Is this gonna be the only workshop that's about Linux from the greatest con recently?
I believe so, but once you've got the virtual machine installed and you're comfortable using the terminal editing text files, you should be good to continue Googling and looking up things as you need if you can't make it to the rest of this.
How do we close Python?
Yeah, so you can press Control D, which means exit.
Control
Control D. Control D.
E.
D.
D. Nah, it's not working.
No, I haven't had it. I just tried it.
It's not working.
To exit Python.
It's fine, it worked for him.
The shortcut didn't work.
Oh,
You
press
exit
Enter and then Control D.
Okay, enter and then control.
Did it work?
Enter, control, D. No.
So this is just like some basic stuff on using the terminal to do basic programming. Usually though, you would want to edit and make a file to run code on your computer. So you would use nano for that purpose. So let's say file.py. We'll just make a basic Python file. You're all familiar with Python, right? Yeah.
At least the basics of it.
So when you're writing a file for Linux, you actually don't need to put, like I did just for the example, but you don't need to put the file type in the file name. So you don't need to use .py or .js or anything like that. Instead, the recommended way is to use what's called a shebang. So you're going to give the path to, I think it's user. What this does is let the computer know how to run the file. So That's how we would write one for a Python file. If this was bash, we would do something similar, /bin/bash. That's the path to the executable for the interpreter for the language. That's a lot of words, but that just means it's telling the computer how to run the file. So you would start your from there. Okay. Now, if we were going to write a Python script that used that package, we would be able to do that from this virtual environment, but not from an external environment. This becomes more useful when you have to work with different environments, but since you're using Python on Linux, you have to set up virtual environments to be able to use those packages. Yeah. Yeah.
I have like a separate question about how to make executable files like for bash. For example, I have a bunch of processes which I need to kill, but they have different IDs all the time. Is there a way for me to get their IDs and kill them and start the things I want to start on these specific ports without like doing it manually all the time and just have one script?
So you want to kill a bunch of processes?
Yes, and then just the same ports start specific files.
Like, to get the IDs of processes, you could use, I don't know if it comes installed. Yeah, top. There's also other programs that work like this, kind of like this, the task manager.
Yeah, but this way doing it manually looks like it's very similar. But how can I will access it automatically?
Okay, that's actually an interesting question. It's a bit outside of the scope, but you can use the, I think it's called PID of, and then that would give you the PID of the program.
Okay.
And then if I did, what's this terminal? One second. Do you know the name of the terminal that's used by default in Linux? Okay. We'll try that. We can do PID of, and then say bash, which is the script we're running. This might break my virtual machine. We run that inside. So this right here runs the bash code inside of kind of like a variable. This makes it as a variable, and then we're going to pass that to pkill.
Okay.
So we get the PID of bash, and then we kill it, and that would kill any bash processes that are running right now.
Okay. And can I put everything in a file? And then
Yeah, so
take one
if I did PID of bash, and I put that into process, then I cat process, it would be that. Now, if I did that again, sorry, it didn't this time add it to the file, instead it replaced the file. So if you want to append to a file instead, you would use double caret, and now if you look inside of that file, it would be in there twice.
And can I put all this bunch of code, like commands, in one file, and then just execute them line by one?
Yeah, absolutely. So that's a bash script. So that's actually what we're getting into right away. We can skip ahead to that though right now. So if we were going to write a bash script, so the shebang for bash would be this one. I'm pretty sure I remember right. It's just bin bash.
How do you say shadow? For all the scripts, but I need to find a different shebang.
Yeah. So for interpreted, you know the difference between interpreted and compiled languages? Okay.
This is JS. I haven't interested in Bash and JS. Like, what is it?
An interpreted language is read and evaluated line by line, whereas a compiled language is converted into a different type of file, and then the computer reads that file. So we're writing interpreted things right now.
Yes.
So the computer reads us one line at a time.
Yeah.
And for interpreted things, we always start by telling it what kind of file it's interpreting.
Okay. So if I want to interpret it, I just write dash one with being Bash, but
Yeah. And that's the path to the bash executable. Okay, so that thing at the top is called a shebang. That's how it's spelled. So I don't have the, see if I can get the last script I was ready. Because that one was kind of just. No, okay. So to write a bash script, you can use all the same stuff we've looked at before. So if I wanted to touch a file to create a file, and then I wanted to delete that file because I changed my mind, and then I wanted to like delete the operating system. This would probably ask for sudo permissions because you're not allowed to just delete the operating system as a regular user. So we would have to put sudo, and then it'll ask for a sudo password while you are writing this file. So don't run this, but all of the stuff we've looked at, actually, all the stuff we've looked at before, you can run in this bash file in order. So you can even change directories in this. So if I did cd/temp and then rm, this is a wildcard character. So this will match with anything. When you do rm start, it deletes everything start. If I did rm a start, it would delete everything that starts with an a. If I did rm star a start, it would remove anything with an a in it.
so now to use this file, I need to go change the execution type, and then you can just
Right. So yeah, like this stuff you were talking about before, you can also store variables. So let's say that's how you would store a variable, and then you wanted to print the variable e, you would do something like that. So here the $sign is accessing the variable e. E is set to the process ID of bash, which is something that we know is running. And then it would print the process ID, or it would print E.
and the Bash is the name of the process.
Bash, yeah, bash is the name of the process. So now if we were to run this, we could do either bash file. Don't notice if he didn't comment out the line about deleting your operating system. But we could do, so it won't let us delete stuff in temp because we don't have permission. But if I did sudo bash file, it does not like that. Oh, this is wrong.
But you didn't change the execution type.
Right, because I was saying bash that, like bash is the interpreter, so bash file, that doesn't require you to set the shebang because the shebang is just telling you to use bash. But if you use /file, that would require you to give the shebang. Sometimes it's smart enough though to pick up that it's a bash file on its own.
Also, for this one by one line execution, I don't need to change that execution type.
So if you were running it like /file, if you run it like that, you would need to change the execution type. I think that's what I called it. Oh. No. Do you remember what I called it? Maybe I didn't save it. But yeah, if you run we'll use file 2 as an example. So if I made that one not executable anymore, and then I tried to run file 2, your permission would be denied. But if I use Python, because it's still a Python file, it already knows to use Python. So you're not executing that file, Python's executing that file. Does that make sense? Okay. All right. So are you guys ready for pizza? Yeah, yeah. Okay, we're gonna take like a break. You guys can grab food. Okay, so we have gone over a majority of the content. We'll just wrap up and then we'll go into stuff that you guys are interested, what you want to hear about. Like, if you have questions on how to script something like that PID of stuff you were talking about, that would work as well. Or even if you're having difficulty with anything on Linux or want help setting stuff up, we can go over that. But I'm going to go over a few more things first and then we can start that.
I don't have anything.
Or should be quiet. Okay. So let's look at SU, that command. So we've already gone over what sudo does, which gives you administrator abilities to run specific code. But you can actually switch users with the SU command. So if we were, the only two users you guys have right now are your own account, which is probably going to be a VBox user, and the root account. So if you wanted to switch to the root, you could do this, or you could just do SU. And I'm assuming, no, okay. I don't know the default password. So yeah, virtual machines, sometimes the default password is not going to be the same as yours. What you can also do though is sudo switch user root. This is kind of circumventing that you don't have root's passwords because you have your password to use sudo. So you're going to use your sudo password to switch to root because you don't have root's password.
What is that?
Because you don't have root's password. But you have super user privileges to switch to root's account. Yeah, so you can use that, and then you have your, I'm actually kind of surprised that one. So what that command did was using your own super user password or sudo, you're switching user to root. And it didn't ask you for root's password to do that because you were doing it in sudo mode, so you don't need permission.
Sudo is basically administrator in MS-DOS version.
Exactly. And SU is switch user, and the account we're switching to is root. Root has a bunch of super user permissions. They're like the administrator. Yep.
So sudo won't work now that you have switched the user.
I don't need sudo anymore because I am root. Root doesn't need sudo for me.
If you switch to some random stuff, you won't be able to use sudo.
Right.
Oh.
Like if you switch to a different user's account that wasn't root, you would have to use their password to use their sudo. So your sudo is different than their sudo. They have
So how
different
can I
passwords.
switch to sudo then? Back to sudo?
Back to sudo.
Yeah.
Sudo's, the user is called root. So to switch back to your user, you can do either, you can write exit, which would leave this session. Like you were in your session, this switch created a new session on top of yours. You can either exit that session by typing exit, or you could do SU the box user,
So
and that would create a third
basically,
session.
the base is that we are the administrator. We access someone else's computer on top of ours.
Right.
Okay.
Yeah.
So we can just exit the application of those.
Right. So if I were to switch back to the box user, and then I exited from here, I would be back into root, and then I exit again, and back where I started. So you can build tons of layers with this. There's not much practical use to it other than the theory, but from root's account, you can switch to anyone because they're the administrator, which could be useful. So let's change root's password. To do that, you switch to the account. You type password. It's not going to ask you for their password because you're root. Root never gets asked for a password. That's just the perks of being the administrator. And you can put in, a new password for that account. So I'm putting mine as changing because that's what the password for my account was. Did that work for everyone? Alright, great. We're not going to do much more in the root user. So, let's look at the grep command and piping. So, let's say you had a big block of text in a file. I wanted to, let's pretend this was a really big file, and you wanted just one line from it. What you can do is use the grep command, which will pull out a certain string. So from file 2, we're going to use grep on it, and we want any line that has E in it. Or actually, that might be every line. We want any line that has the number 1 in it. I put that in backwards. So you're going to grep 1 from file 2, and it will give you just lines that have that. That is useful for scripting if you might be figuring out right now. Let's say you wanted 2 lines after every time you see E. You can do -A2. That'll give you 2 lines after every occurrence of E. If you want it before, similarly, you use before 2. That gives you 2 lines before, or if you want it before and after C, that gives you 2 lines before and after every line. This is useful. The reason we're going over grep is so I can show you how pipes work. So let's say we were just a cat to read that file. Now we can pass that output into a different program, grep, let's say. So that output has been passed into grep, and then again we're just going to search for 1. It does the same thing. So what pipes do is they take the output and they pass it to the next argument. They're like connecting the 2 commands. So this does the same thing as grep 1 from file 2. Does that make sense for everyone? Like pipes are kind of confusing and grep itself can be confusing. Do you have a question? No. Okay, John. Yeah, John. Okay. Yeah.
So standard output is a file.
Standard output is a file? Yes.
That's true.
So if you wanted to, let's say you ran this and you wanted to put that to somewhere different than standard output, what standard output is just the output of the terminal. So right here, this is your standard output. And if you wanted to put that somewhere different than standard output, which is kind of like a file, you can put it into, let's say, file 3. And now, if you read file 3, it's going to have that output. And if you wanted to append, same as before, you can use 2 carets instead of 1. So, does everyone understand how pipes work? Yeah, it's called like piping, because you use a pipe character.
It's going to take one and put the pipe character and put it on
Yeah,
the
so like
end of
the output is passed to the next thing.
What do you mean by pass?
Given, like, as an input. It becomes an input.
Why didn't, like, okay, you got an input. Why did it assume that it's going to be, like, after grep 1, even if you wrote?
So in this it's kind of smart in the way you do this because it will know also if I put -A3, if I put A3 there, it will work if I put, I think I can even put actually I'm not sure, I'm pretty sure I can put -A3 here. Yeah, it still works. Yeah, it is pretty smart. It'll know what you're talking about most of the time. Sometimes if it's not working, just refer to the man pages. So we're gonna go over man now. The command is short for manual. And if you are wondering how something like grep works, you put man grep. So you put the word there. And then you can look through this. It'll open a manual on that. And what we used was -A and -B, -C. They give you after, before and after with C. Man just tells you how to use each command properly and everything that command can do.
Is there a list of commands, like a function to call a list of commands?
Sorry, it can be.
Is there a function which tells us a list of commands which we can use?
Yeah, it's like the documentation. Man gives you the documentation. Yep.
I think the question is there a command to give a list of all of the commands that we have?
Oh, that is tough because there are a ton. I think if you just, no. So you can look in /bin. These are all commands you can run. ls/bin. There's lots of different ones though. If you looked in user bin, these are all, the way you can find all the places where commands would be is you want to echo and then path. So this path is a special variable of everywhere your computer looks to look for executables. And you can modify this path to add more of those. So if I said, say path equals path, and then /home/ the box user, if I did this, maybe, I'm not sure if you're allowed to use spaces actually. Yeah, so now if you echo path, at the end it has that there. So now if I try file 2, I think it was, caps lock. So right, we had to make this executable. File 2 has to be executable to be executed. And now if I ran file 2, it, okay, ignore that. It's not too necessary to change your path, but you can. I don't know why it didn't. Oh, yeah. I put a typo in it, that's why. So when you're using bin, the way you exit a file is using, you press escape, this, like this isn't bin, this is now, but if you had bin, you would do that to exit a file. And that's what I tried to do, and that's what the typo was. But this isn't bin, so that didn't work. So now if you try file 2, it runs that program. So you can add different directories, like if you have your own binaries folder, you can add that to your path. And if you want that to run every session, because now if you open a new terminal and you try file 2, it doesn't know what you're talking about. So a script that's run every time you open a terminal is called bashrc or .bashrc. So you can edit your startup script. It runs every time you open a terminal. And at the bottom, you can put anything you want. So if you put pwd and now you open a terminal, it prints your working directory. Or if you wanted to modify your path.
How does the file call?
Yeah, I'll show you again in a second. So you put that file back in there. Or this. So it's called .bashrc. Did you get all that? Okay. So some other kind of interesting commands. You've got du, and you run that on a file. Sorry. File 2, it tells you how big that file is. So that one, I think that's 4 kilobytes. Could be wrong. You put it in human readable form. Yeah, 4 kilobytes. You can run this, I think you can run this on directories too. So that ran it on the entire directory. The entire directory would be 130 megabytes. All of those files that start with a dot, so things like .ssh, those are hidden files on Linux. So if I do touch dot Rafiq or something, and then ILS, Rafiq's not here, I didn't touch Rafiq. But then I can still remove like the evidence that I touched Rafiq, and it's gone. So that's how you make a hidden file. You can still see hidden files with ls-a, and the way I know that is because I've done man ls, and then -a does not ignore the first one. -a shows all. Okay, there's just a few more I want to go over. So when you want to download something from download my EO7 lab, we were doing an academic offense and taking my code. So let's say we wanted this file. We could find a link to get it, or find a link for the code. And, well, this would be for git clone. But if we wanted to download the zip, this link would download the zip. So you copy this link. And then if I did wget, and then that link, it downloads that link. The reason this is important is because you can access these terminals on different devices without accessing their browser. So if you tried to download this, it would download to your local machine. But if you're in the terminal and you run wget, it downloads to the current directory. So we can't really do SSH to other devices, but we can go over going into these terminals on other devices. So we're going to have to enable a background process before we can do that. To do that, we're going to enable the SSH server, which lets people do secure shells into your machine when they're on the same network if they have your password. To do that, I think this, you guys will be able to run this. Does it work? Okay, you will have to use, you have to install this server. Yeah, so you have to run that command. I already have it, so it's shorted. Were you all able to install SSH already? Yeah, okay, so now you can enable the SSH server on your device. No? What's the error message? Are you sure you installed SSH? So you run this command to install SSH. It works. And then you can't start it. That is weird. It works on my machine. Does it work for anyone else? Okay. Okay. I don't know what to tell you. It works on my machine. So assuming this did work for you, you can then SSH into your own computer, which is not as cool as SSHing into a server or someone else's computer because it lets you control that server or their computer. But if I were to SSH myself, then it asks your password. And now I'm connected to this computer through the internet to this computer. We can't do it between each other's computers right now because the university, we've tried this before, the university Wi-Fi is smart enough not to let users connect to each other because of security risk and blah, blah, blah. But that is the gist of how Secure Shell would work, assuming you can install it and run. What we were doing was running a server, which lets you connect to yourself. So you can still connect to other people, just no one can connect to you if your server's not running. Let's say someone was connecting to you on your network, you wanted your IP address, you could just run IP, and the second argument is ADDR. This is too much to look at, so you would grep it, and local IPs start with 192. Oh, we're on an IPv6. If they're on a different network, that's a bit more advanced because you have to port the router and stuff like that, which is out of scope for this. But if you're on the same Wi-Fi network and you're not using IPv6, this would show you your address. Looking at it though, you can find it. Usually. This might even be, I don't know if it would let, it probably wouldn't let you use this though because that's going through the router and the router doesn't let different computers interact. Okay, so before we wrap up, is there anything you guys want to go over? Any questions you have, how to code something in Linux or make something work in Linux? Any questions? Yep.
What are the different types of shells?
So there's bash, there's sh, there's zsh. No one cares about anything except bash. Sh works a lot like bash, but it has less features. ZSH is like, you got too carried away configuring your setup. There might be more, but really bash is more than enough. And then scripts work, everything's made through bash. So you might run into weird syntax errors using ZSH. Yeah.
Where can you do bash scripts?
So something I did was kind of interesting. Do you know what OCR is?
Yeah.
Exactly. So it can take an image and convert it to text. So what we wrote was a program that we were having to copy stuff from the source assignment to our assignment, copy the question. It took too long. So instead we spent a few hours writing a script that's like 3 lines long that does it for us. So I'll get the code for that up.
Can we get code?
Yeah, you can. It might not work if you're on X11, but it'll work on Wayland. I'll explain the difference right away. Exactly. So let me see if I can.
So did you send it to like AI API?
The clipboard doesn't work, but it's like a few lines long, so I can probably just copy it. So we start with the shebang, because this is a bash script. And then we use WL-paste, which pastes on Wayland. If you're not using Wayland, I'll explain the difference. Probably you are. I'll explain what Wayland is soon, but if you're on Wayland, WL-paste your thing, and we put it into the temporary file folder, and we called it clip.png without a slash. Then from there, we would copy, and then we'd run a command. So on Linux, there's this package called Tesseract, which runs all the OCR for you, and it runs it on your own machine. It doesn't use a remote server or anything, just using your own hardware. So you run Tesseract. So we run Tesseract on the clip that we just saved as a file, and then we copy that to our clipboard. So I don't know how to use Nano that well. UJ is bin or VS Code, but this comes with Nano pre-installed.
It has
It does. I don't want to configure it though. Yeah, so this is the code. So what this would do is take what's on your clipboard, send it to a file, just so you can access it later. And then the Tesseract opens that file and outputs text. And then we copy that text. So we've used this to copy assignment questions onto our solution page instead of having to retype everything.
Can't you just copy and paste using a mouse?
Yeah. So
This is doing the same thing.
you would print screen to take the selection, copy that, run this command, which is connected to a keybind, and then paste, and it would paste the text.
Can you demonstrate?
Yeah.
Yeah.
It's different. You can just see Control C, Control V.
Let me change how this displays. So I have to leave the virtual machine to do this.
Yes, plain text.
Um, So there's a slow resolution. Okay, so I'm gonna take a screenshot of this. And it's not always perfect, some characters it's not good at. So I copy that. I have it keybinded to Windows V, and then
Feature. And it's because
so now I've got that on my clipboard and I can paste it. So that's the stuff that was in the screenshot. It converted it to code or to text, and then I pasted the text. Okay, yeah, I can send that. There's also a way to do it with Xclip, which is what I have below. And that way works better because then it can also paste it at the same time. But Wayland won't let you do that. So the difference between Wayland and X11 is kind of like really back-end stuff. Low level, how the display driver, what's the word for it? The display, I think it's called the compositor, how that renders things onto your page, onto your screen. And most are switching to Wayland, but a lot are on X11, especially if you have a NVIDIA graphics card, you might still be on X11 instead of Wayland, just because NVIDIA hasn't open sourced a lot of their drivers for their graphics card, making it harder for developers to work with them to develop things such as Wayland. Does that make sense? Yeah, okay. want to come up here?